Oh, it's working. Okay, cool. We're gonna get going. Welcome to Cloud Native Madison's December meetup. Thanks everybody for coming out. Really happy to see a nice sized crowd here. Just a little bit of meetup business before we have our main speaker, Nick, come up here. So we're gonna be taking the month of January off. We usually have these the first week of the month, and so with the holidays, we're gonna be taking a month off, give everybody some time for rest and relaxation. We will be looking for additional speakers coming, into the new year here. So, if you're interested in giving any sort of talk in any sort of format, whether it's participating in a panel, giving a lightning talk, longer format talk, we'd love to hear from you. You reach out to Kurt or I through the Meetup messaging system. We're happy to help you develop that talk, talk about ideas as well. We're always particularly looking for more folks who are either new to CNCF or people who are developers. I think in general, a lot of the CNCF stuff can kind of come off as a little operations and infrastructure-y, but as it continues to mature, we're really looking to hear from more developers who are working in this space. So if you have any ideas, like I said, reach out on Meetup, and we'd love to hear from you. Normally at this time we do kind of like last month in Cloud Native. I thought since last month was the national conference, CloudNativeCon / KubernetesCon, we just do a little bit of a retrospective on that as a number of us here from Integral were able to attend. And so there's a lot of recurring themes in, the fourth year of KubeCon. It's funny to think that Kubernetes is only 5 years old, which is of course kind of the seed of KubeCon, or of Cloud Native. But in the fourth year, you really seen the space start to mature a bit. And so there's a lot of talk at the conference around kind of patterns of how do people actually use these technologies. You've got Kubernetes as kind of the substrate for what most people are doing in this space, but then there's all these other tools on top of that, whether it's service mesh or any kind of observability tooling. List goes on and on. And so there's a lot of really interesting talks around kind of GitOps as sort of the de facto DevOps workflow to kind of harness and manage a lot of these technologies. There's also a lot of talk around continuous delivery, right? So how do we get our applications actually out into these architectures based on cloud native technologies? And a couple of interesting things were happening there. One is there's 2 open source projects out there that are actually merging. Argo, which is actually from the folks at Intuit, if you're familiar with like Mint or various tax software they make, they have an open source offering. And then Flux from Weaveworks, they're both kind of GitOps continuous delivery systems made for Kubernetes, and they're actually merging their projects together. So that's actually some really interesting development to me. It'll be good to get those communities together and kind of make sure that they're all going in the same direction. And then another big tool in this space is Spinnaker, and that continues to see a lot of interesting growth. And the last one is another tool from Weaveworks called Flagger, which is actually a tool to allow you to do progressive delivery of your applications out to Kubernetes. So you can manage if you're using a service mesh like Linkerd or Istio, Flagger basically allows you to, push your new version of your application out there in kind of a canary or a blue-green style, and then progressively, based on metrics it's collecting, automatically continue to roll that out or roll it back. So you can imagine telling Flagger you care about like service latency or error rates and things like that, and then it can kind of automatically continue to roll out or roll back your deployments for you. So that's a space that's continuing to evolve very quickly. The other big theme I wanted to touch on is sort of Kubernetes not just as a container orchestration platform, but really as a platform for building other platforms. And what I mean by that is, if you break down what Kubernetes really gives you, right, it's really kind of a generic API server that allows you to have declarative API calls made against it, and then machinery around that to allow you to write code to then pay attention to those particular types of resources that Kubernetes has that you care about, and then kind of make the state of the cluster converge on what you've defined. And so, out of the box, you get that for containers, right? When you define a deployment, you say, I've got this container, I want to run 3 replicas of it, maybe I've got some config and some secrets I want to mount to it, and Kubernetes just kind of takes that declarative definition and converges on that state. What people are starting to say now is, why can't I do that for other things I care about? Like maybe I want to bring my database technology into Kubernetes, or maybe I want to actually bring my CI/CD workflow into Kubernetes. And so there's all kinds of tooling popping up to help with that. KubeBuilder is kind of the one from the main Kubernetes project, and that is the kernel of Operator SDK, which is kind of mostly in Go, but you can also use Helm and Ansible to develop your very own operators to do similar things to what Kubernetes can do for things like containers and services. But there's also other frameworks popping up around different languages. So Kopf, I hope I'm pronouncing that correctly, around Python. and then also for Java. And that's really cool because, up until very recently, if you really wanted to develop against Kubernetes, you're pretty locked into using Go. And Go is a great language, but not everybody knows it. It's pretty new. And so it's good to see that the ecosystem is actually growing to allow people with different backgrounds, different preferred languages to develop against Kubernetes as kind of your core platform. So look for those projects to evolve in the future. And kind of the last thing I wanted to call out is that my take on where the industry is right now is we're all really asking ourselves, how do we, as a community, not as vendors or companies, but as a community, how do we make Kubernetes and everything else around it as easy as possible for developers and operators to consume? So if you've got a really good fluency in a lot of these technologies, maybe you've got good DevOps people, you can kind of assemble what kind of starts to look like a platform as a service out of all the different cloud native projects. But what's kind of missing is like that glue. Like you'd like to give one interface out to your developers, maybe a small number of interfaces out to your developers to allow them to easily leverage all those technologies without having to be an expert in Kubernetes, an expert in Istio or Linkerd, expert in Prometheus, yada, yada, yada. And so this is where I think as end users, we really have an opportunity here to kind of come forward, tell our stories about how we're handling this internally, either at our own open source projects or at our companies or as individuals, and to really start to flesh out some more patterns and processes that we can talk about. And so if you are doing these kind of things at your company or individually, love to have you come up and give a talk. It doesn't have to be the most technical thing, but talk about the problems you're kind of trying to solve, how you're approaching it, and what you've maybe come to as part of that. Finally, as we're at the end of the year here, I did want to say thank you to some people who worked behind the scenes to make these events a success. We've been doing this since March of this year. And so I wanted to call out Dave Goodwin, Derek Novotny, Kyle Howard, and Clarice Hnilika. I'm sure I butchered that. Sorry, Clarice. It takes a lot to make these events a success, and these folks have all really contributed to the logistics, the sponsorships, and everything else besides like content and community building that it takes to run a meetup group like this. So if we could all give them a warm round of applause. Thanks. And finally, to our sponsors tonight, Invisia. They came to us and said they'd like to help us host one of these events. They're very active in the meetup space in general, if you're not familiar with them. We have Josh here tonight, who I'm sure would love to have a conversation with you. With that, I will turn it over to our speaker tonight, Nick Schultz.
All right. So tonight we're going to be talking about modernizing. Switch this. So, yeah, sounds better. All right, so tonight we're going to be talking about modernizing applications with Docker, and this is going to be focused a lot on your legacy monolithic applications and how we're going to get those out to the cloud, and then once they're there, actually break apart that monolith into a microservice architecture. So to start, how many of you have used Docker at some point? All right, so most of you. How many of you are actually running containers in production? All right, so almost half. All right, so about a year ago, it would have been maybe 1 or 2 people. Containers have picked up a lot recently. For you that haven't used it, we're just going to do a quick intro to Docker. All right, so what is Docker? Docker is this tool that is supposed to make our lives simpler by solving the problem of it works on my machine. And for any of you that ever told anyone that or had someone tell you that, it's a frustrating conversation to have. You get it working one place, you take it somewhere else, and it doesn't work. Whose problem is it? Is it the developers? Is it the operators? Docker wants to solve that. So the idea is if I can make it run in a container locally, I can pick that container up and take it into my test environment, which could be Linux, and I could be running on Windows, and it should still work. I can take that into my production environment without any additional setup, and it should still work. So that idea of build, ship, and run any app anywhere, that's really what Docker is trying to solve. And for you guys that have done Java before, this is what Java wanted to do way back when. The idea was you write your code once, you pick it up, you run it here, you pick it up, you run it there. The problem was it never worked that way because if I run it on Windows, I'm using one SDK. If I'm running it on Linux, I'm using a different SDK. If I'm running it on IBM, I'm using their proprietary SDK. So you'd always find these little things that made it different. And even then, you still had to build out your environment. With Docker, you're shipping that environment with the application. All right, so developers love Docker. We just did a talk in Milwaukee about this, and we're doing one in Chicago. Docker is the #1 most wanted platform, the #2 most loved platform. I don't remember what #1 was for that, but it's the #3 most used platform. The only two above it are Windows and Linux. So as far as the market goes, Docker has definitely grown a lot in the past couple of years. Now there has been the buyout of Docker Enterprise, but Docker itself and the platform still exists. It's still part of the Docker company. All right, so what are containers? Containers are a way that we're gonna package our software into these standardized units for deployment. So the idea is that today, if I wanna run Debian, Ubuntu, Alpine, I'm gonna have 3 different VMs, because I'm gonna have to have a guest OS on them that can run this. And then I'm going to, on Ubuntu, spin up MySQL, and then I'm gonna run my PHP application on that. For the Debian server, I'm installing Java and Tomcat, and it's all additional work I have to do. With Docker, I can run all of those on the same kernel, isolated from each other, and they should all still work. So why are we doing Docker? Why are we doing containers? The ideas behind it are faster deployments, you get increased efficiencies, less failures, reduced costs, and you get that isolation security. So things that you would be doing with VMs, but you're typically not. And when we look at them, why don't we do this with VMs? Because VMs have been around a lot longer. Why is this something that hasn't been solved yet? So when you look at a VM over here, you've got your guest OS. On top of there, you've got your binaries and libs and all of your other setup that you had to do. And then on top of that, you're gonna run your application. When you look at Docker, on that host OS, you're gonna run Docker. You don't have that guest OS overhead anymore. You can share the bins and libs because the images themselves are immutable. So I can have multiple applications using those same libraries without impacting each other. There's gonna be a small writable layer on top of that, but they can't actually impact that underlying image. And then on top of that, I run my applications. So when we show this to people, it's like, okay, I get the guest OS is more heavyweight, but I could still do this with VMs. And the answer is you totally could, but you don't, because your VMs are like pets. The way it works with the VM is you spin that up, you go out there, you manually configure things. You spend time patching it, and you do all of these things. And if you lose that VM, you're gonna be hurting for a while, because it's gonna take you all of that time to spin up a new one. Containers are cattle. I lose a container, I don't care, I spin another one up. If I'm using an orchestrator like Swarm or Kubernetes, it's gonna do it for me. When you have a VM and you see there's a security issue, you have to go out and patch it. You're taking your dog to the vet. When you have a problem with a container and you find there's a security vulnerability, you don't take it to the vet, you go and you turn it into hamburger and you get a new container. That's just the way it works. So, could you do this with VMs? You totally could, but usually you don't. Now we're seeing more things like with infrastructure as code, but that's lagging further behind. We're working with clients now where it's like, we've got Terraform, we've got Ansible, we can build these things, but nobody goes and actually builds those scripts. They do everything by hand. And then what happens? I lose that VM. How did we have that stood up? Oh, we'll just do this AMI, we'll get it out there, and then, oh crap, what was that other thing that we had on there? Did anyone document that? If you're doing that with your application, it's gonna take even longer. Here, we can get away with just running really that basic host OS, spinning up Docker, and then just letting Kubernetes or Docker Swarm or whatever throw a bunch of work over to it and say, here, go and work now. So any questions on kind of the high level of Docker's containers and images? All right. So this presentation was originally written by Elton Stolman, and it was focused on getting more people in the Windows community to use Docker. We're going to talk about some of the differences between Windows and Linux. We're not going to really focus too much on Windows. How many in here are actually running on Windows? No one. Okay, perfect. So we can, you keep your hand down. We can talk trash about them then. All right, so the way it works is, here's my Windows server. I've got 3 applications running. None of the applications realize they're running in Docker. They do not see each other. They're all isolated from each other. And as far as Windows knows, these 3 applications are running. If you actually look at what's running, it's going to show you that the exe, the console exe here, the Windows server and the SQL server, they're all running. So I've got IIS, I've got a console application, I've got SQL server running. Same thing on Linux. The host OS really doesn't pay attention to the fact that Docker's running. It just sees that there's several processes running, and you'll see the PIDs for those. Internally to the container, in Linux, you will always see it as PID 1. Windows will not be that way. But for you guys, since you're not doing, you're not running on Windows platforms, the only time that you'd ever really have to worry about writing Windows containers is if you are trying to make your application portable to where you're going to hand it off to someone else and they might need to run it on a Windows platform. An example would be like OpenJDK. So the tooling around that, they run on all the different flavors of Linux, but then they also now run on all the different flavors of Windows. If you don't have that, if you're taking your stuff out to the cloud, stay on Linux. There's never a reason to go to Windows at that point. If you're on Windows, go to Linux. So the reason why is when you're looking at Windows versus Linux, I can take my Windows container. Why is this? Oh, yeah, okay. So I can try to take my Windows container, I can run it on my Windows platform and it works fine. I can take Nginx and I can run that on Linux, it works fine. I will not be able to run a Windows container on Linux. Microsoft has come out and said they will never support letting anyone run Windows containers on a Linux platform. If you want to take Windows applications and run them on Linux, find something that already supports Linux. So if you're running fullstack.net, stop running fullstack.net, run .NET Core. .NET Core runs on Linux. If you're running SQL Server 2012, run SQL Server 2017 because that runs on Linux. So Microsoft's feeling is, we're going to give you stuff that runs on Linux. We're not going to backtrack and port all of that other stuff off. We're not going to run Windows containers because of licensing on Linux either. But if you have Linux containers, you can run those on either. So that Nginx container I can pick up, I can put it on Linux, I can put it on Windows, it doesn't matter. When you are looking at managing these hybrid environments, you can actually use whatever you want to connect to them. So remoting in from a central machine, you can do PowerShell from Windows and go against Linux. You can use Bash and go against Windows. It doesn't matter. It's your machine interacting with the Docker API. It's exactly the same on both. So you're making the exact same calls regardless of what host OS it's running on. And then when you're managing Docker in a hybrid swarm, you've got your managers, you've got your workers. Docker will figure out how to, Docker Swarm would figure out how to do this. I believe, so Kubernetes Windows support was in beta. I think it's out of beta now, and they also support Windows. So you can do this in either, but again, it's that same thing. You're gonna manage against the swarm or against the Kubernetes cluster, and the orchestrator is gonna handle delegating out to all of those nodes. You don't have to care anything about it. You just fire commands against that with whatever tool that you're using. All right. So now that we are out of that, let's talk about modernizing applications with Docker. So how many of you have monolithic applications that you're dealing with it? Yeah, a lot of us. Always a pain in the ass. Always the first thing that everyone says, oh, I don't want to deal with that. Let the new guys handle that. I'm going to go work on the greenfield applications. And why is that? It's because it usually takes forever to test, forever to set up. When you have those new developers and it's coming in, there's all of that tribal knowledge that you've got to get to them. So usually there's that one person that's been there for years now. They've worked on that application since before some of us were born, and they know how it works. And it only works on their machine. And we need to get it the hell off their machine and out to the cloud. So how are we going to do that? Stop pointing at that. All right, so for this, and like I said, so this is based on Elton Stoneman's example. If you want it, on github.com under Docker samples, the application exists. This is, again, written for Windows. So if you were running Linux, you can look at it from a high level. You wouldn't actually be able to run the examples. But what we have here is a web application designed to sign up new prospects. Monolithic in nature, it is an old ASP.NET 3.forms web forms application with a SQL Server Express database. So just getting someone stood up on that means on my laptop, I need the following. And this is the kind of things we don't think about. I have to install the .NET framework. I have to install the MS Build and NuGet tool chains in order to be able to build the application. I have to have an application hosted up, so I need IIS. I have my database that I have to install because I need my local copy of it so that I'm not trampling over other people's work. When you're doing this with Java, it's the same thing. You've got your SDK installed. If you have multiple applications, because there's that one application that still runs on Java 5 and we never got around to updating it, and don't take it to 7 or 8 because, oh my God, it won't work well. You don't want to touch those, but you still have to support them. So you pull them down and you install and you try to make it work without breaking all the other stuff you have going on. You install Maven, you install Gradle, you have Tomcat or JBoss or hell, even WebLogic or WebSphere installed. You've got your, well, you won't have an Oracle database, but you'll have like a Postgres database or something locally that you're going to run. And it's all of that work that you have to do just to even get started. So before I can even do anything with the application, I need to go through all of this work. Then on top of that, I got to get all the tribal knowledge from that guy that's been here for 30 years and say, hey, how the hell does this thing actually work? Because I pulled it down and I tried to compile it and it doesn't work. And oh yeah, you have to have this thing in this directory in order for it to work. And oh, build this first and then copy the jar from there over to here because we don't have that manually working. Lots of headaches with that, but that's typically what happens with these monolithic applications. And this is just for my local environment. When I get out to test, I've got to do the exact same thing, and then I've got to do that in QA and prod. When you're starting to stand up these new servers, where it's, oh yeah, we're getting rid of that VM, that one's getting deprecated finally because we're switching off of IBM AIX and we're going to CentOS because it's cheaper. Great, now somebody has to go through and they have to guess, if we don't have it documented, on all of the environment stuff that needed to be set up to make this monolith work. When we look at containers, the only prereq I have, is Docker. So a new developer coming in, the one thing they need on their machine is Docker. The idea behind this is I come in, I pull it from GitHub, let's say, I run my Docker commands to spin it up, and then whether I'm using Kubernetes or Swarm or Docker Compose, it doesn't matter. I run something, I get the application stood up. So the only thing I'm really dependent on is Docker. Everything else is containerized. The build chain's containerized, the runtime's containerized, the database is containerized. So now that I've got that, spinning up new developers is trivial. Get your laptop, install Docker, go. On top of this, yeah, if I'm a Java developer, maybe I install the SDK, I install IntelliJ, or I do VS Code, and in my case, I just use it like a text editor. But that's really what you need. Because I have it containerized now, I can pick that monolith up and take it out to my server. So now that work that I had to do before of all of that setup and getting it out to that new environment, that's gone. It's, again, install Docker, run the application. Same thing you did locally, do it out there. Now that I've got that, I can take it out to any of these cloud providers. So I can take it to Amazon, I can take it to Microsoft, I can take it to Google, I can take it to, I can't remember the one with the shark. But I'm also not locked into these vendors. So I can go to Amazon, I can sit there for a while and say, you know what, I looked at the price, Azure's actually gonna be cheaper for me to run this, and take it over to Azure. We've got some deal in place, or somebody already has an account with them. I'm not locked in, I can pick this up, and I don't have that same problem that I had with the monolithic application, where I'm having to constantly install all of this stuff. And I get into that situation of now I'm locked into a vendor because I don't want to have to rip this down and look for another several weeks of trying to get stuff set up for it. So our first goal to get there is to containerize the application. There's two ways that we can do this. The first is we build a Docker file from scratch. How many people have built a Docker file from scratch? All right, yeah, half of you. This is going to be the most common way forward, and this is going to be the preferred way forward. So the idea here is you're going to pick your base image, you're going to add in all of your components, and then you're going to have your application. So you've got your built artifacts. You can either do a multi-stage build, where you're going to actually put your build chain right into that image, and then take the artifact from there and carry it forward to the next layer. Or you can just take existing artifacts. We see this with some clients where I've already got my CI tool stood up, it builds a jar, I just want to take that jar and throw it into a container and move it forward. So you have either option. The other option is you can use a tool like Image to Docker. With this, what happens is it's a command line tool, it extracts the application from either a VHD or a WIM file, and it builds you an image. The problem with this is it will only be the runtime piece, and the tools are not very good. They usually will grab way more than they need to because they don't really know what the hell your application is. So when you go and look at the image, it's going to be massive in terms of the number of settings that they're going through. If you're trying to do something quick, and I just need to get this old application, especially for things where I lost the source code, this is the way that you're gonna do it. So if you've got that old monolith that's sitting out on some server somewhere and you need to get it the hell off of there and you need to get it out to the cloud, Image to Docker is a possibility. If you are taking an application and going through all of these other steps, your best bet is always going to be to build the Docker file yourself. It's going to have just the pieces that you need in it, so it's going to be smaller, it's going to be more secure, and you're going to know exactly what's going on with it. So for the example tonight, we're going to go that route. So our first step is we just want to get this application into containers. What that means, no code changes, pick the application up and containerize it. Where we see issues with this is the first thing people want to do is they want to jump right in and start re-architecting their application. It's a possibility. The problem you have with that is now you've got tons of moving parts. And we'll actually see in this example where he's doing some of that, and I disagree with it, but it was his example to write. So here's what our Docker file looks like for our database. So you see we start with SQL Server Express up there. We set some environment variables. Do not do this, the password here, in the environment variable. Environment variables are available at runtime. When your container crashes, it throws all of the environment variables out to the console, which means now your password is just out on some console. So do not put passwords in environment variables. With build kit, you can actually stick them in through secrets if you need to do stuff at build time. When you're doing actual runtime, whether it's Kubernetes or Docker Swarm, secrets are available on either platform. Go that route. It's going to be much more secure, and you're not going to have this problem. You'll see here we're also voluming in the data path. So that's our way of, if I lose the container, I maintain my data. So it's cattle, but we're keeping it around that memory. If I don't have that and I lose my database, I've lost all my data, which might be preferable for some of these things where you're doing some quick end-to-end tests or something like that. So I spin this database up as part of my CI process. I quickly jam a bunch of data into it, and then I run my tests and I throw it away. And I don't care about backing it up because at that point I mutated the data and I'm never going to use it again. I don't need a volume out. For this, if I actually care about the data, I'm going to want to volume it out. We set some working directories, we copy in everything below this Docker DB. We set the command that we want to run, and then one of the important things here is we added a health check. So the health check is what the orchestrator is going to use to determine if the application is actually healthy or not. With Linux, your application's running on PID 1. If PID 1 dies, your container's dead, and the orchestrator is going to whack it. So it's going to see that the container's not doing what it's supposed to be doing, and it's going to kill it off. Anything short of that, the orchestrator is just going to say, looks fine to me. Here what we're saying is, if I can't get data out of the database, even if the database is still running, it's useless to me. So in that case, if you see this, kill the container off and spin a new one up. So health checks are important when you're dealing with orchestrators, and you're not necessarily afraid of PID 1 going down, but there are other concerns that you have, where if I lose access to this, my application is more or less useless despite the fact that it's still running. The next one is the web application. So again, for this one, what you'll see here is this is an example of a multi-stage build. So you'll see we have two from statements here. The first one is where we're going to do our code compile from. So up here we've got this Docker samples, which is something that Elton built. It's actually in the project somewhere else. And we specified that as the builder. So what we're doing here is we're taking in the full SDK, and we're going to actually compile all of our code. So that's where we run through our MS build here. We do the NuGet restore. If you're doing Node, this is where you do like your npm installs. You do your AOT build. If you're doing Java, this is where you use Maven or Gradle to install all of your packages, and then you do your compile. Do not take that to production. The reason you don't want to take that to production is if I take that to production, it's like, yeah, I got my jar, but I also have all my source code in a compiler. Somebody Docker execs into my container, they can modify my code, rebuild it, and actually have me running a broken version of my application. If you are doing Node, the concern isn't necessarily that. It's the fact that all of a sudden you look and you have a 2.5 gig image because Node decided it wanted to check out every JavaScript library that was ever written because all of them could be useful at some point. So with that, you end up with, you always want your image to be small. The reason you want your image to be small is it typically tends to be more secure. The other thing is it's much easier to spin up when I have to throw stuff over to another server, because again, it's cattle. Something died off, I need to go run it on another VM. If it's 2.5 gigs, I have to download that 2.5 gigs each time. If it's already been running on that server, it's there and it's immutable, so it'll just spin up another one. But it's always that work of downloading it that first time, and that delays your ability to get your application up fast. So try to make it as small as possible. From a security standpoint, you never want your compiler there. And typically what you do with an application like Node, you do your AOT build, you get back your HTML and JavaScript, take it and throw it to the lightest weight project you can, which is typically going to be like an Nginx, and just host the web page. All right, so from here then, we take the next image, and you'll see that this is a Windows Server core, and this is just going to have what we need to run the application. We're going to set up some environment variables, set our working directory, and here again it's running IIS. Typically this is where you're going to have, if it's Java and you're doing Spring, you're going to have like a CMD run the Java jar command. If it's Nginx, you're just going to have it do the host. It's already running Nginx in the background. You'll see here that they have this entry point. So rather than doing a command, everything is going to go back and hit this start PS1. So with a command, typically the way it works is you have an entry point set as bash, and the command is the options that you want to pass into bash to get it to run your stuff. So when you're doing Java, it's Java jar, whatever my jar is. And that says, hey bash, go spin this up. With this, we replace bash with this PowerShell. So every command I run, unless I overwrite entry point, goes and hits that PowerShell script. So this is one way of avoiding people running commands just against your container. So if that is a concern that you have, I know like with traffic, they have a script running as their entry point. So you can't easily Docker exec in unless you overwrite the entry point. That is an option for this. Some people do it, most people don't, but it is there. Down here you'll see, so everywhere where we have the copy, this is pulling from the machine that I'm currently on into my image. Where I have this -- from builder, this is actually pulling from this previous image and bringing it down here. So all I'm doing is I'm going to carry forward my jar, my compiled website or my transcompiled website, my DLL, whatever, and I'm pulling that forward. The rest of this up here gets garbaged. Once I have the artifact that I care about, or artifacts I care about from that, I throw all of that away. The only reason you have that around is for caching when you're running through your CI process on the build and you want it to run faster. What will happen is each one of these is a different layer in Docker. They're all cached. Docker actually will do a SHA for all the files that are in to determine if anything changed. So as you're running through your CI process, if my source code here under signup didn't change, and none of the above stuff up there changed either, it'll actually skip through all of this until it gets to the next copy. Because at that point, it's already done it. It doesn't expect anything to change, and that's where you see some benefits in your CI process. So this is one of those things where like when people are going and changing the README, today, if you're not doing your builds inside a container, changing the README requires a full build of your application. When you've got a monolithic application, that can be minutes to a half hour to an hour, depending on how in-depth your build is and how much it has to do. If you can skip that because it's not useful, skip it. And this is a way of doing that. So at the end of this, we have our containers. So we have images for both the web app and the database. We need a way to run them. In this case, he's using Docker Compose. You'll see we're spinning up some services here. So here's our DB. There's the image for it. So that's the image name that we would have built locally. Here's our sign-up app. We're exposing some ports. So this is how I'm going to make it available on my machine. We're putting this depends on. Ignore this. This is going away. This is something that is unique to Docker Compose that Docker's not carrying forward. It does not exist in Kubernetes or Docker Swarm. The idea behind this is supposed to make the sign-up app wait on the database. The way it works in reality is as soon as the database says it's running, which doesn't mean it's useful, it just means the container's running, it spins up the next one. If your application starts up and tries to hit the database right away and fails, then if you're doing Compose, it could just be dead. If you're doing Swarm or Kubernetes, it might spin for a while and just die. So the way it works is if you actually need to do dependencies between your applications when you're spinning them up, you actually have to write it into the image or into the orchestration tool to say, here's what happens if the other service isn't ready yet. The last thing that we have down here is a network. So this is one of the things where Kubernetes and Docker differ a little bit. So Kubernetes, they want more of a flat network where everything can communicate. Docker's the opposite. Docker does not want anything to communicate unless you specify it directly. So in this case, we're going to allow these two to connect by building this AppNet network, which is actually going to be a NAT network. That's going to allow the database to talk to the application. Without that, even though they're running on the same machine, they're not allowed to interact. With Kubernetes, they would be allowed to interact. You could actually do service discovery on them, unless you're using a tool like Calico and you start putting in rules that say that certain things aren't allowed to talk. At that point, it works the exact same way. One of the other things I want to point out with this is the way that we actually connect to the database. So I'm going to connect to my web application through localhost. I'm not going to connect to my database that way. Do I have the connection string? Where does he put the connection string in this? All right, so in here, we've got this DB connection string path. It should have been in this one here. The way it works is you're not going to connect to your database over localhost. For one, we're not exposing a port. Because we're not exposing a port, there's going to be nothing for us directly to connect to. Localhost inside a container is that container. It does not know that it is running in a container. It has no idea about what else is running. When you're doing this, whether it is Kubernetes or Docker Swarm or Compose, you're going to use the service name to interact, and you're going to be doing service discovery. So you can use that service name as a DNS. The orchestrator will figure out how to wire your stuff with Kubernetes as long as they're on a network, as long as they're deployed, they're on kind of that shared network and they can talk. If they're in a pod, they can talk over localhost. So if your applications are deployed in a pod together, localhost is an option. Anything short of that in Kubernetes, you go service name. Docker is the same. It's always going to be service name. There is no ability to talk to localhost unless you're running the applications inside the same container, which you should avoid at all costs. You don't want multiple PIDs running because it's going to be a nightmare to manage. If one of them goes down and the other one's still up, it becomes harder to scale and harder to support. So in that case, what happens, you put them both on a network and you allow them to communicate that way. All right, so for the next slide, what we want to talk about then is, now that I've got it in a container, I can take all of this and take it anywhere I want. That's great. Now I got it out in the cloud. So it's there, it's working, but it's still a nightmare to support. So yeah, it's easy for new developers to get it pulled down and actually do what they need to do, but it's still a monolithic application. We need to break it up. So what we need to do is break up pieces that change frequently. So anything that this is the part of the application that's always changing, break that out. The reason you're going to break that out is you're going to get faster releases because you only have to worry about that. So I can really focus on just testing that piece and then running the overall end-to-end piece. I don't have to recompile the entire application for that one service, or in this case, we'll be looking at a UI that changes. Anything that changes seldomly, same thing. Break it out, put it in a separate service so that I don't have to touch it. The data layer never changes, it's always going to be the same. Fantastic. Put it in a separate service. I don't have to touch it. It can be 1.0 forever and ever, and that one can just stay, and I'll worry about all the other stuff that changes. Any parts that have problems, so performance issues, buggy code, you can break those out and actually run them accordingly. I can actually scale things with performance issues, so we'll be looking at one of those coming up. Right now, the way it works is with this container, if I want to scale, I scale the entire monolith. I can leave the database as a single instance, but I'm going to run multiple instances of my monolith. Monoliths tend to take up a lot of resources, so you usually don't want to scale them. You want to scale those individual services. To do that, you have to break them out. You can do it in the code, but again, then it's something else you're managing inside the code. And you're going to be running those same services, or you're going to have to do your own thread management inside the application, which you're typically going to want to avoid. Last part is reuse. And this is going to be your first step towards microservices. We've been places where we've seen clients where they just copy and paste code throughout various services. And the reason they did that is everything is a monolith. I don't want to have to depend on anything else. If we break that out and we start to decompose it, we can take that service, we can make it available, and everyone can use it, which is the way it should be to begin with. Now, not everyone needs a copy of the tables, and we have to worry about keeping them all up to date. We can have one service that handles that for us. So any questions about what we're going to be looking at breaking out? Whoop. What happened there? All right. All right, so here's where we're at. Here's where we want to get to after a couple of changes. So people look at this and say, well, this is way more complex. The reason it's not is we're still going to use either Compose or Swarm or Kubernetes to tie all this together. So from my side, it's still a single command that I run to build my application and get it up and running. If it's that way, it doesn't matter if it's one service or 100 services. I run one thing and it all comes up. All right, so now we're going to look at a performance fix. So here's our application. It's out in the cloud. They notice that synchronous saves, as we're trying to save the prospect information that's coming through, is really the bottleneck of the application. How do we make it better? So the way we're going to do that is we're going to spin off a service that can actually do the saves for us, and we're going to add a queue to the mix. Right now, you typically don't do that because it's another tool that you have to install. Even if it's RabbitMQ, it's something that your developers have to install on their machine and get stood up. If you're using something like IBM MQ, you probably don't have licensing for it. And it's really a pain in the ass when you have stuff like IBM MQ on your test, QA, and prod boxes, but you can't use it locally. So you start to use, just JMS backed by whatever. And yeah, it works, and then you get out and it doesn't work anymore. So in this case, the queue that I use in production is the same one I can use here. So our performance fix for asynchronous saves is to introduce that queue and introduce that new service. Here's our existing project structure. So you see here, we've just got a single solution with a single project. And here's what it looks like afterwards. Now, when I said that you don't want to have multiple things going on at the same time, Elton violates that a lot in his examples. So you'll see here, he broke out a lot of different things. So he broke out entities and numerous other things to allow him to share this code back and forth. It's not that you can't do it, it's just that it makes it harder to debug when you have problems. Because now you're not sure, is it the new container I stood up that's having a problem, or is it something with the underlying code because I changed a whole bunch of it? So what this looks like from a web app side, and here's another change he made. You'll see that we went from 3.5 to 4.7. So again, now I'm changing the runtime and the compile time of this. Again, it's more changes I don't want to have to deal with. But the big thing is here, we have this message queue that we added, which is nats, the message queue, and then 422, so the port. That's the only change that we needed to make to this. Now, like I said, he made numerous other changes, but that's really the only thing that we had to change in that image, is we're going to rebuild it, we're going to tell it that there's a queue there now, and other than that, we could leave the rest of the image alone. For our messaging app, you'll see here we start with the official Microsoft.NET Framework SDK. We don't have to have our own version of it anymore. We pull the application in, we build it, we copy it forward to the actual runtime. We set up the DB connection path, what the queue is so that it can connect to it, where its root is, and then we start the application. When you look at the compose, you'll see that we have a message queue, we have our sign-up application, and we have our save handler. The one thing that you'll see is missing now from this compose is the database. The reason is because as we got up through the environments, we decided we did not want to containerize databases. Containerized databases typically don't perform as the in-house options you have with AWS, Azure, Google. So usually the way it works is locally you containerize your database because it's one less dependency you have to work on. As you're going up through the environments, you don't containerize the database. You just go with an in-house option. Let Amazon handle it. You'll get better performance that way. So we've got our message queue, we've got our sign-up app. You'll see they're all on the same network, so all of them can communicate. With this, the messaging app can technically talk directly to the sign-up app, and the sign-up app can talk to the messaging app. Where this is problematic is when I don't want them to talk, because at some point, the next developer in can go, I don't understand how queues work. I'm going to have this call this directly and do the saves. I'm back to synchronous saves. So this is where if you're doing Kubernetes and you've got that flat network, you want to implement something like Calico to prevent those things from being able to talk. With Docker Swarm, the way you do that is you just put these two on different networks and they can't talk. They can both talk to the queue, but they're not allowed to talk to each other. For my local compose file, you'll see the way you can do it with compose is you can actually string multiple compose files together and it'll merge them together. So what we do here is we set this up and we add in that the database. So locally, I'm going to run my base compose plus my local compose to stand up the whole application. When I get to test, I'm not going to do that. There, I'm going to have another one that's going to actually tell me the location of the database. So any questions on what we did there? It's really just take that service out, throw it somewhere else, and then hook it in. All right. So for the next one, we're going to look at quicker changes. How many people have to work with someone from sales or marketing? Just me? All right. Yeah, he's sitting back there, so I can talk crap about him. They decide they don't like the UI. They constantly want it to change. We need it flashier. We need this button moved over here. That's great. Other than the fact that every time you change the HTML, because I'm not using a CMS, I have to go in and rebuild the entire application. Let's rip that out and put it somewhere else. It's, again, I want to go as simple as possible, and especially if it's just static HTML. I don't even have to really unit test that. At most, I would be doing some UI testing of it. As long as the button's there, my end-to-end tests are going to function yet. So it's really the end-to-end test and then the UI test if I have any. But without that, I'm doing a full regression test for every one of these. So now I break the UI out and put it off separately. So now changing the home page doesn't impact the main application. How do we go about this? Well, we went from this to this. In this case, we only add a single project. How does our web application change? We add one more environment file, which says the app settings path is going to be somewhere. And what this is going to do is this app settings path is going to give us an app settings properties file, which is going to tell us where the home page lives. Here's what the home page application looks like. It is a nano server where we copied in that one HTML file. And that's all we run for that. Again, you do this with Nginx, it's the same thing. You take the one HTML file, you throw it over there. How do you make that work? Well, in this case, you do it by having the app settings look for this sign up app homepage. So this is what we're going to call our service. So what we do is we throw that into the app settings file. We load that in somehow. You could do this as an environment file. You can do this as a config file. There's numerous ways to get it to work. But really, it's just telling the application, hey, when you load, here's where your homepage is. So that's all we did for that. So we broke that one piece out that kept changing, and now we get to leave the rest of the application alone, and we change that one thing. And now our testing is down to really just going to be end-to-end and maybe some UI testing. What does our compose file look like? Well, now we've got the 4 applications. You see we've got the message queue, the sign up, and the save. And again, because Elton wanted to go a little bit nuts, he introduced the Belk stack as well. So you see he's got Elasticsearch and Kibana in here. That was for another piece that he was working on. The real focus of this was the home page, but because he likes to make multiple changes at once, that also got introduced. But really, that's what the goal of that was, is just take that one piece, roll it off. It's, again, a single compose file, a single command that we're running, and I spin my application up. The difference is now when I'm running this through CI, all of this other stuff, which is going to take way more time to build, gets ignored. We don't change any of this. We just run that one image build, which is as simple as copy this file in and go. So any questions about what we did there? All right. So the last part we're going to talk to is the modernization spectrum. So what we looked at here was getting an application just out to the cloud. Our first thing is just make it run out there. We could leave it, but we decided to break it up. So that is one option. And that's going to be our first one. So migrate as is. Take the binaries, take the setup, take the artifacts, get it into a container, get it out there. That's your first option. This is where most people start with the application. The reason is it's the fastest. So take what you got, throw it out in the cloud. Next is adopt the platform idioms. So this is where configuration, monitoring, login, those kind of things get set up. So this is where you start to look at compose, you start to look at, hey, I want to send up the bulk stack, I want to change the way my application works. Maybe I'm going to introduce something like twist lock and things like that. Adapt to a new runtime. So this is where you start to introduce the fault tolerance, scaling, and statelessness. This is where you start to actually rebuild the application a bit. So you do a little bit with the config and monitoring. But when you start looking at fault tolerance and scaling, that's where if you've got a monolithic application, you have to start breaking it apart in order for it to start doing that. Scaling a monolith tends to just eat up resources, and you're scaling things unnecessarily. Statelessness is also a huge one, because if you're maintaining state and you're not volume mounting, you're going to have problems, because as soon as that container goes down, I've lost my state. If I'm volume mounting, I maintain that state as long as I'm on that same instance or I have a networked volume mount. So that becomes one of those things that as you're getting out to the cloud, I spun it up, it worked, but oh, I only did a volume mount on that one machine, and now when I go over to that other machine, I don't have my, my volume anymore. So you have to pay attention to that when you have stateful applications. If it's stateless, it doesn't matter. So stateless is always going to be preferred with containers. The next one is extracting the key features. So this is where you focus on performance, functionality, the fast updates. So this is where we were taking that application and taking out things like the home page and stuff like that and saying, break that out separately, let's make this faster. Let's really make our CI process hum. Let's make our sprints easier where we can take these things off and just focus on a service rather than focusing on the entire monolith at one time. The last is going to be rebuild and renew. This is where you take the application, you say, we know what it did, scrap it, rebuild, knowing that we've got all of these underlying technologies. I know I'm using Kubernetes. So with that in mind, how would I build the application now knowing that? Because back in 1996 when we wrote this the first time, we didn't have that. How are we going to do it now? So that's where you go. Now, a lot of people look at this when you start saying containers and you're going to microservice enable. It's an option, but it's not the only option available. Anywhere along this spectrum is fine. Wherever you see yourself landing works, as long as it works for you. If you are here, great. You rebuild your application. Maybe the business is cool with that. You might have a business where we're working with a client. They had, I think, Windows 2012 servers. You have to get off of those by the end of the year. We're not going to rebuild the application. We're going to take it into a container and throw it somewhere else. They're only going to tolerate migrating as is. Once it's in a container, we can take it across the spectrum, but we don't have to jump right to this just because we're containerizing an application. Any questions? Test, test.
How the changes in the CI pipeline when you're actually migrating through the spectrum?
So it depends on how you have your application set up. In this case, because he had a single solution, what we're going to do is we're going to have one CI pipeline that's going to build numerous images. It's going to push all of those artifacts up to whatever our artifact hosting site is. And then really the part that we care about is going to be that configuration file. So whether it's Compose, Swarm, or Kubernetes, it's that piece that we really care about because that's going to go back and pull those down and break that out. So what happens is you start from a single application. In this case, it would be like one image, and you start to break that out. Now, what you'll see with most people is, especially when you're looking at Kubernetes and you're building these services, they will actually break that out into separate projects so that they can all be managed separately, and they run as separate services. So what happens then is your CI process changes to you build that one image, and then you're probably going to auto-deploy it right away.
So say for example, we have a Bitbucket which basically generates jar files.
Mm-hmm.
We keep that, and then we put another stage into there where it basically takes that jar file, puts into a container, and that's the way.
Yeah, if you're doing the as is and you want to keep that the way it is, yeah, so what you do is you take the jar file, then you copy the jar file into the image. What you probably go to next is after that, you take that building of the jar file and you put that in the image as well as part of the multi-stage build. So that's your next iteration going forward. Then as you're looking at that and you say, well, this is a monolith, that's where you start to break out those services. You leave that project, but you take that source code that goes into the new service, you throw that into another Bitbucket project, you build another CI pipeline that builds a different service.
I will mention that we have some lovely Google Cloud battery banks for anybody who wants to ask a question this evening. Tell you from experience, you get at least 2 or 3 smartphone charges off of that. My question for you is, just in the clients you work with here in Wisconsin, where are we at in terms of companies adopting these sort of patterns and tools, particularly on maybe the sort of Microsoft-centric shops? Are you mostly still seeing early adopters starting to go down the Docker and like .NET Core building for Linux runtime kind of thing, or do we start to see more mature companies adopt these patterns as well?
We're seeing, I would say maybe 10 to 20% of companies are more mature, where they've started this and they've already started on that migration path. A lot of them are at the beginning and they're not really sure how to get ready. What we see with startups is, we go into a startup, they already have this. They knew what Kubernetes was a year ago. They had already made it part of their plan. When you start looking at the big enterprises, they've heard of it, they want to do it, but they don't know how to get there. So that's where you see like, some of them you go in and they've got a CI pipeline defined, but it's like this. They build a jar and they're used to putting that jar up into, let's say, Artifactory. And then someone grabs that and they throw it off into another server. Maybe they even have something like Octopus that does it for them. But that's usually where we see them where they're stuck, is here's what I have. I want to do this. I don't know how to do this. So that's where we're going in and helping them. Well, we'll get into a container, and now that you've got it in a container, how do you carry it forward? What's your orchestrator look like? What we see with a lot of them is they want to do Kubernetes, but because of where they're at, they usually start with Docker Swarm. So Docker Swarm becomes the gateway to Kubernetes. Developers love Kubernetes. If the developers get their pick, they're going to do Kubernetes. The admins prefer Docker Swarm. Docker Swarm is more monolithic in nature. It's easier to stand up. Its batteries included. So what they'll do is they'll actually build Swarm. They can get a quick POC going. At some point, you're going to find a use case for Kubernetes. Once you find that use case for Kubernetes, you're going to start switching applications over to it. Now, you can run them side by side, and it'll still work. But typically what we see at that point is once they start spinning up Kubernetes, Swarm goes down and everything migrates over.
What are some pointers for kind of convincing your stakeholders why this is advantageous?
Usually where we start is kind of that same thing we talked about with VMs. What happens when something goes wrong? Right now what we see is everyone always kind of works in that happy path of, we've built it, it works, it's good. I set the VM up once, I don't care about how I did it, it's always going to be that way. You will always be able to go through your history and find times where that didn't happen. I lost a week because of this. At the client I'm at currently, we lost a day, even with doing Terraform scripts and Ansible, because somebody went into the box and made a manual configuration change that nobody knew about, and without that, the application didn't work the way we expected it to. And the reason was it couldn't SSH in because it was behind a networked load balancer and the IP kept changing. So they configured it so that it would allow that. We lose a day. It's really easy to go back in and say, yeah, here's why we're doing infrastructure as a code and why we have to focus on this. When you have an application and you're trying to migrate it off of stuff, and you're saying, do you want to pay for, with like that 2012 example, do you want to pay me every couple of years to spend weeks picking this application up and taking it somewhere else? Or would you rather me take that time right now to put it into a container and then I can take it somewhere else? And oh, by the way, we get the benefits of high availability and failover and those things out of the box. And usually we find that as a way to get a win with the stakeholders. They don't necessarily understand it, but when you start explaining it to those as the wins that you get with it, they usually get on board pretty quick with it, especially when it's usually going to be about the same time to do either or. Where we see struggles is you go to a stakeholder, and you say, hey, I want to containerize the application. They say, we're not even touching it. Don't touch it. That's where we see the problems, because if there's not an ongoing project, if there's not a need, it's difficult to sell them that there is a need, because again, they don't understand the technology.
Other questions for Nick? All right, thank you very much.
You got one back here?
Do you have any restrictions on like team size for going for something like this? Like my group is 2 developers and 2 sysadmins. Would we be able to still get the benefits of this?
Yeah. So yeah, we see this even with single-person teams, because what it comes down at is at some point your team's either going to scale up or you're going to swap resources out, and the more simplified your process is, the easier it is at that point to do that scaling. Your resources, right now the way it works is there's going to be that tribal knowledge that you have to share. There's the setup work, there's all of this. So yeah, you've got it for those people, but it's what happens when that next person comes on. And have you documented all of the things you need to do to get your application stood up? Usually there's going to be a handful of gotchas that come up. So yeah, we see this with the client that I'm working with right now. There's 3 of us kind of on the DevOps side, and they have 35 developers that are kind of going through this process with us. We have another one where it was myself and another guy, and then 2 developers. So very similar to the size that you had. And what we started looking at there was, we didn't even containerize the application to begin with. We containerized some of the tooling around the application. So things that they didn't have that they knew they needed, it was easier to start off with, let's do this as a containerization process. So in this case, it was some database migration tool. We containerized that. Once we had containers in place, we could take it to the broader team and say, hey, this is already there. Now you can take that monolith, pick it up, and actually do the same thing. So when we left them, that's where they were heading. We're actually going back to talk to them. It sounds like they're actually sort of microservice enabling the application. So it's, again, legacy.NET. I think it's a 4.5 application. They're switching to .NET Core and running on Linux because apparently they're done with Windows. So, yeah.
So, especially in a bigger organization where you have multiple applications, monoliths, do you do any analysis on the context boundary of those applications? For example, if you have a, say, e-commerce application which works. So
Yeah.
So how do you approach that? Because one of the things, especially for Docker Swarm, we were specifying is that because it cannot communicate with each other, you probably have to do that exercise upfront to see that, okay, my application communicates with a CICS, a MQ, a RabbitMQ, a IBM MQ. So how that exercise is done?
Yeah, so the first thing we do is we do an architectural review for them. We look at what the various pieces are. So like you said, I interact with MQ, I interact with the database, I have several services. We don't have to do it all at once. First thing we want to do is I want to get to something that I can actually run on the developer's machine. So I want to take that queue, that database, and those couple of services, and if I can't get them all down because I might not own the service I connect to, that might be another team. Well, then we look at how can we mock that out. So we'll use something like, oh, I can't remember its name now. It's, what's the mocking framework called? No, it's not Makito. It's actually a service that you stand up that will do like RESTful calls back to your application. Montebank. So you can actually use something like that, and you can actually spin that up in place of there. So now when I run locally and I spin my application up, I spin up Montebank there to actually stand in for that service. So now I can actually do my full development and testing locally with those containers. I've got my queue and everything. It might not be ideal because if it's MQ, I'm probably not running that in a queue even locally. So there is still going to be that work of now when I go to go to test, QA, and wherever, I'm swapping things in and out, and there still might be some bumps because I didn't containerize the whole thing. But usually that's what we see. Once they have that, then we look at, okay, now that we've kind of picked this up and gotten this into a container at least as best we could, we start to look at those containers and say, does it make sense to start breaking some of this stuff out? When you're looking at large companies and they have monoliths, they typically avoid trying to do that. And usually what you see there is the reason they like doing like Docker Swarm is they build stacks. So I'm going to take my application, I'm going to turn it into 10 services, but I'm going to deploy it as a single application through a stack. When you're looking at actual cloud native applications and people coming in, they want to do microservices where everything's kind of broken out and you deploy and it just hooks in and it works. We don't see that as much with big companies. They're just not ready for that because it's different than what they've done. They've always had someone kind of support this overarching application. So with larger companies, what you'll see is that's where Swarm and Stacks kind of start off with. But once they have the services out, breaking those out and kind of spreading those across different teams, and then they can support the microservices correctly.